Welcome to this video lecture on measurement and psychometrics. I think this will be a helpful video lecture to you because we're going to review how a test is constructed, and this will lead to subsequent video lectures about test reliability and validity. We're going to be talking about four topics in this video lecture: standardized versus non-standardized assessment, norm versus criterion referenced assessment, raw scores versus standard scores, and measurement scales using the NOIR acronym. Let's begin with standardized versus non-standardized assessments. Standardized assessments follow the same procedure every time. This ensures fairness, accuracy, and reliability. An instrument example is the Beck Anxiety Inventory, which asks the same questions in the same order to every test taker. Of course, standardized assessments still take skill on the part of the administrator. So, for example, the adult attachment interview and the Rorschach both require the administrator to know when to ask follow-ups, what pieces of information are most important to ask follow-up questions about. In addition, standardized assessments are fairly formal, meaning usually you stick to the test protocol and you do not deviate from that. Non-standardized assessments are more flexible and more individualized. What do we mean by this? Well, you're able to deviate from the test protocol, if there even is one, and ask questions that are, that follow up on things that the client hasn't asked about yet, or things they have that seem tangential to the original topic. You can also share your own experiences or share your own emotional experience of what the client is saying. Because of this flexibility, non-standardized assessments are more prone to bias. They're also less reliable, and some may say less fair, because different test takers are asked different kinds of questions. They're also more heavily reliant on the administrator's skill. For example, the structured clinical interview, if you ask that at intake, it still requires skill to know what kinds of symptoms you want to be asking about, how to ask follow-up questions, how to ask about what the client isn't talking about. There are also informal assessments because, again, you can deviate from a test protocol even if it does exist. Let's look now at norm versus criterion referenced assessment. A norm referenced assessment compares test takers. It's interested in where scores fall relative to each other. So, for example, if one person takes a test, one individual, we're interested in how their scores fall relative to the population norm group who originally took the test. This is important because it helps us to kind of quantify the importance of the test taker's result relative to other people. To understand norm referenced assessment, we have to understand the bell curve. If you aren't familiar with things like T-scores, Z-scores, and percentile ranks, don't worry, we're going to review them in just a few minutes. An example of this is the MMPI, which has set a criterion score of 65, a T-score of 65, to qualify for clinical significance. So if you have a T-score of 65 or above on, say, the depression scale, you have clinically significant depression according to the MMPI. A criterion referenced assessment is where scores fall relative to the content of the test. Scores are assessed according to an established standard. We're not interested in how scores compare to other test takers so much. So, for example, second grade reading level is about whether or not you have the knowledge and skills of a second grade reader. There is of course a problem with cut scores, which is that they're basically developed by humans. For example, the Beck Depression Inventory was put together by content experts who identified the symptoms needed to meet the criteria for depression and the amount of severity of those symptoms needed to meet that criteria. And if you meet that criteria by having enough symptoms with enough severity, you meet the criteria for depression. It's not based, though, on other test takers, meaning it could be inaccurate in terms of how much of something exists within a population. You should also know that most licensure exams are criterion referenced. For example, the National Clinical Mental Health Counselors exam is a criterion referenced exam. The test company, the National Board for Certified Counselors, basically decides the degree of knowledge and skill you should have in that case-based exam in order to pass it and meet the qualifications for licensure. It's not based on whether or not you are at the 50th percentile of other test takers. It's just interested in, do you or do you not meet that criteria for passing? Okay, now we're going to talk about raw scores and standard scores. Raw scores aren't that useful and interpretable, unfortunately. I'll give you two examples. Sally's self-reported depression score in the MMPI was 9. Sally achieved a raw score of 9 on an achievement test. When we read these, we don't know what to do with the 9. What does the 9 mean? Well, in order to understand what the 9 means, we have to translate it into a standard score. Here are two of the same examples using standard scores. Sally's MMPI profile indicated depression in the clinical range, a T-score of 67. Sally's achievement score was at the 91st percentile for her age group, second grade. Okay, now we have some information that's very useful to us. We know that Sally is clinically depressed based on her comparison with a norm group. We also know that her achievement score is actually quite high. It's higher than would be expected, or at least at the higher end of the achievement level for second graders. Okay, to fully understand standard scores, we have to review the bell curve. Now, I'm going to spend a couple of minutes doing this, understanding though that you may well need to ask follow-up questions in class to really get this, and that's totally fine, so please bring questions into class. If you look right in the middle of the bell curve, you see a standard deviation of 0, if you just cut it right down the middle. If you now move down to the next line, you see it has a cumulative percentage of 50%. What that means is 50% of test takers score at the middle, the average. That's how the bell curve works. Now if you look at percentiles, you'll see that 50 cumulative percentage is also a 50th percentile, meaning if you score at 0 standard deviations right at the average, you also have a 50th percentile score. Now go down one more line to z-scores. You'll notice that a standard deviation of 0 is the same as a z-score of 0. Same with a standard deviation of +1 is also a z-score of +1, and a standard deviation of -1 is a z-score of -1. In other words, z-scores follow standard deviations. Okay? T-scores also follow standard deviations, though their numerical formula is a little different. So when you have a standard deviation of 0, you have a t-score of 50. And when you have a standard deviation of +1, you have a t-score of 60. And likewise, when you have a standard deviation of -1, you have a t-score of 40. Okay? Remember that the MMPI requires a t-score of 65 for clinical significance, which if you scale up the chart and look at the bell curve, you realize that if you look at cumulative percentages, only about maybe, I don't know, 90%, 95%, somewhere in that range of people, 90 to 95% of people are going to score below 65 t-score. So in other words, only 5% of people, maybe a slightly more 7%, are going to score above 65 t-score. It's fairly unusual, abnormal you might say, to have a t-score of 65 or above on something like a depression scale. Okay, so that's how that works. In case you're unfamiliar, basically the way that the bell curve works is that you have an average, which is right down the middle, and standard deviations, which help you understand the distribution of the bell curve. If you have a standard deviation of +1 or -1, if you add those together, 68% of people, 34% plus 34%, those two slices, 68% of people score between -1 to +1 standard deviations. Okay, so most people score within 1 standard deviation from the mean. Similarly, if you go from -2 standard deviations to +2 standard deviations, you'll notice the cumulative percentages 97.7 on +2 and 2.3% on -2 standard deviations. If you do the math, 97.7 minus 2.3, you get 95.4%, meaning 95.4% of people score within 2 standard deviations from the mean. And if you get someone who scores less than 2 standard deviations, or more than 2 standard deviations from the mean, it's pretty unusual that you get that kind of a score. This was used to identify things like intellectual disability, which is a IQ score of 70 or less, and that's based as an IQ score of 70 is the same as at 2 standard deviations below the mean. And gifted status, which is an IQ score of 130, this is also the same as 2 standard deviations above the mean. Okay, I don't expect you to know the IQ scales right now, but all I hope you'll get is how the bell curve works. Again, bring questions to class if you don't understand this. Okay, next we're going to review measurement scales using the NOIR acronym: nominal, ordinal, interval, and ratio. It's important to mention just from the get-go that nominal scales also include dichotomous items such as yes, no, true, false. The reason for this is that nominal data usually describes dichotomous groups: male versus female, conservative versus liberal, group 1 versus group 2, such as male equals 1, female equals 2. Okay? So we're just interested in groups. That's what nominal data are. They're just groups. Because of its lack of variability, it is limited in the area of statistical analysis. We have what's called range restriction, which means we only have 2, 3, at the very most 4 data points. And when you have a very limited number of data points, for example, you can only have a rating or a score of 1, 2, 3, or 4, group 1, 2, 3, or 4, it's very hard to do statistics on that. Usually you need to have a much wider range of potential scores in order to do statistics. So because of this, nominal data have limited use in testing except to discuss trends. For example, if we want to know whether females do better on verbal tests of the Wechsler Intelligence Scale for children, we may compare male-female scores in a group. Does that make sense? Okay. Next, we're on ordinal data. Ordinal data are actually very commonly used in psychometric instruments. They are often used in behavioral rating scales and survey instruments, for example, service satisfaction instruments. Data in ordinal scales are expressed on a continuum through things like a Likert scale, beginning with things like frequently to never, strongly agree to strongly disagree. You see there that you have a continuum. Usually you have 4 to 5 data points on that continuum. So for example, you might have strongly disagree as the last data point, then disagree, then neither agree or disagree, then agree, then strongly agree. That's 5 data points. Okay, that's a basic rating scale. There are measurement issues with ordinal scales. The weight assigned to each level of the data scale obviously varies from person to person. Here's an example. Let's say that I indicate that I strongly agree with a certain statement, and you say that you strongly agree with that same statement too. That doesn't mean that our strongly agree is the same. For example, I may vehemently believe in that statement with all of my being, and you may indicate strongly agree because, well, it's slightly more than agree, so I guess I'll go with strongly agree. Does that make sense? In other words, there is still a degree of variation in those rating scales, in those actual data points. So that's a problem. In addition, we have range restriction, which I've talked about before, and we have self-report issues. A lot of psychometric instruments use self-report, and this is a problem. Here's a good example. The Beck Depression Inventory uses ordinal scales. For example, it asks, how sad have you felt in the past week? 0, not at all, 1, a little bit, 2, moderate, 3, a lot. Okay? You can bias your response because it's self-report. You could say, for example, a lot when you haven't felt that a lot, or you could say not at all when you have felt that a lot. Why would you do that? Well, potentially because you misperceive your own experience. That's possible. People can over or underemphasize what they're experiencing. For example, some people have a greater sensitivity to emotional distress or pain. In addition to that, you may frankly want to somewhat finesse or alter the outcomes of a report. This is especially pertinent in forensic settings if you're trying to avoid legal trouble, for example. So there are issues with self-report, though I will say it is very common, unfortunately, in psychometric testing. In addition, data analysis is limited to simple correlations involving ranks. Again, we can't do very much statistically with ordinal data. Interval data is next, interval scales. Interval scales are a little better than ordinal scales in terms of statistics, more useful to us. Interval scales assume that scores are equidistant from one another, but not that there is an absolute zero. What do we mean by equidistant? I'm going to give you an example of IQ. Okay, SATs and GREs, same deal, but let's use IQ for now. If someone has a score of 85, that is 15 IQ points from the mean of 100, and that is the same distance from the mean as an IQ of 115, which is 15 IQ points higher than 100. So in other words, instead of what we had with ordinal scales, which is my version of very satisfied is very different from your version of very satisfied, 85 is definitely 15 points from 100, and that is definitely the same distance as is 115 from 100. And that can be quite useful when we're trying to understand how one person's score falls relative to other people's. Okay, so IQ scales use intervals. IQ uses interval scales, and it's quite useful. The difference between interval and ratio, as we'll see, is that there is no such score as zero. There's no absolute zero, so you can't have an IQ of 0. I mean, you could never test that anyway. No one would be. You wouldn't be testable if you had an IQ of 0. You wouldn't be able to answer any questions. And we'll talk about why that true zero is important in just a minute. Data at this level at interval scales are more meaningful because data points can be compared with more sophisticated statistics. For example, IQ scales, and we talked about norm referenced and the normal curve and why that's so useful just a few moments ago. Ratio is the highest level of measurement. Ratio is interval measurement plus the existence of a true zero, an absolute zero. This can be assessed using all statistical evaluations, including sophisticated multivariate analyses such as regression, factor analysis, things like that. There's no range restriction. Here is an example of a ratio scale. Okay, hours of sleep that a person has had in the past week. That has a true score of 0. Believe it or not, you can get 0 sleep in the past week, and can vary quite a lot. Can go all the way to 50, 60, 70 hours of sleep, maybe even more than that. Another example would be if you ask someone for the amount of money that they have spent on a certain endeavor. Again, that's ratio scale, because you could have spent $0 or you could have spent thousands of dollars. Ratio scale is quite useful because with ratios you can start comparing actual, as you might imagine, ratios. So for example, if I spend $5 on, I don't know, on an activity such as gambling, let's just say, and you spend $20 on an activity such as gambling, I can say you spent 4 times as much as me on gambling in that week, let's say, okay? And that's very useful because then we can start getting into ratios and how important my score or amount is relative to your score or amount. Okay. Okay, we're going to talk a bit about test development before we close. We've talked so far about how tests are constructed, and now we need to understand a bit about how items are constructed, how tests are actually developed. Here are some general rules of thumb for instrument design. First, if you're using multiple choice, you should only have 3 to 5 options per item. If you have more than that, it gets confusing. If you have less than that, it's too little. You should avoid overlapping alternatives, meaning you should make sure that each answer choice is different, quite different. The length of response options should be about the same. Okay. You should avoid use of negatives or double negatives. By the way, in terms of response options, if you have a really, really long response option, always pick that one because it's usually the right answer. Avoid use of negatives or double negatives. This is because, again, it's asking more about the test taker's skill in answering action tests rather than whether or not the person has knowledge or is truly reporting what they're experiencing. When you start asking double negatives, you start getting into problems because you're really testing about a person's attention to detail, whether or not a person understands double negatives. You want to avoid use of all of the above or none of the above because, again, it really is going to bias how people respond. Most of the time, all of the above or none of the above is the correct answer selection, and if it's not, again, you're asking people how good a test taker are you versus how much knowledge do you have about this, or how much are you reporting experiencing a certain phenomenon. Distractors should also be plausible answers, meaning if you're going to use something that's obviously false, don't make it obviously false, otherwise no one's going to select it and it's going to be a useless answer choice. The test should not be measuring test-taking ability. That's kind of the bottom line here. This is difficult to do, and I think when designing an instrument that measures what you're meant to measure, it's an art and a science, and it requires a lot of practice and a lot of professional training. Okay, so we've reviewed standardized, non-standardized assessment, norm and criterion referenced assessment. We've also looked at the NOIR acronym, and hopefully this will give you the grounding needed to start learning more about reliability and validity in assessment.